for this video. We'll continue the notes for 0.3. This next section is solving quadratic equations by the square root property. So the steps here are to first get your problem to where it's parentheses, some number times x plus some number close parentheses squared equals some number. So for 2a, that's already done for us. For 2b, we're going to have to do a little bit of work for that. Once it's in that form, like it is for 2a, we're going to take the square root of both sides. On the left-hand side, the square root and the squared are going to cancel, so we're just going to have whatever was inside the parentheses. On the right-hand side, though, the square root of that number needs a positive and a negative sign so that we get our two answers that we need for quadratic. Because x is squared in a quadratic, there should be two answers. This plus and minus is on the outside of the square root as opposed to the negative that's on the inside of the square root that we've had in previous problems that produces the I. Once you get to this level that I'm labeling step 3, you're going to separate those and solve them one at a time. Ax plus b equals the positive square root of c, whatever those are for the problem, and ax plus b equals the negative square root of c, using the skills that you practiced from 0.1. So I'm going to go ahead and work through 2a. So parentheses x minus 2 close parentheses squared equals negative 36 is already in the correct format for step 1. So I can take the square root of both sides. And when I do that, on the left-hand side, the square and the square root cancel, so it's just x minus 2. On the right-hand side, I have a positive and a negative square root of 36, and that simplifies similar to what we did in the previous notes. Negative 1 times 36, and 36 is 6 times 6. So we have a pair of 6 and a negative 1 means I is going to come out, and we don't have anything left over that doesn't have a pair. So x minus 2 equals positive or negative 6 times I. We separate those into 2. X minus 2 equals positive 6i, and x minus 2 equals negative 6i to solve, to get our final answer. So we're going to add 2 to both sides, and this is going to equal x. X is going to equal 2 plus 6i. Those are not like terms. The 2 is just a number. The 6i has an I. They are not like terms. They don't combine. The nice thing about these is the other answer is very similar work, very similar format, but it's going to be x equals 2 minus 6i. So the real part, the I, the part that doesn't have an I, the real part is the same in both, but the imaginary part, the part that does have an I, one of them should be positive, one of them should be negative. So that's a good way to check for reasonableness. For number 2b, this is not in the form to match step number 1 because it's got a 2 on the outside. So the first thing I need to do is divide both sides by 2. We get parentheses x minus 3 close parentheses squared on the left equals 4 divided by 2 is 2 on the right. Now I can take the square root of both sides. So x minus 3, because the square and the square root cancel on the left, is equal to positive and negative square root of 2 on the right. Square root of 2 doesn't factor any further, so that doesn't simplify. There's no negative, there's no pairs, nothing is going to happen to that. So we split this up into our two possibilities. X minus 3 equals positive square root of 2, or x minus 3 equals negative square root of 2. Add 3 to both sides. Here, again, we don't have any like terms. It is possible that you will get some like terms sometimes in some of the problems. Since the MyOpen math problems are randomly generated, everybody gets different numbers. You get different numbers each time you try a new problem. So it's possible you will have like terms, but 3 is just a plain integer number, while square root of 2 has the square root, so those are not like terms. Similar solving by adding 3 on both sides for the other equation produces x equals 3 minus the square root of 2. So you see again the pattern of the 3 is the same, but the square root of 2, one of them is positive, one of them is negative. The last section for the 0.3 notes is solving quadratic equations using the quadratic formula. So there are times when factoring doesn't work. There are times when the square root property doesn't work. When those work, we want to use them because they're faster, but there are times they don't work. So we need to know what to do when the other slightly faster methods don't work. So the steps for quadratic formula work problems are to first make sure it's in the proper form. The proper form for quadratic formula is set equal to 0. So everything on one side, left or right. Sometimes that will be done for you, like 3a. Sometimes that won't be done for you, like 3b. So you get the problem in the correct form if necessary. Identify what your A, B, and C are from your problem so that you can plug into the quadratic formula. This is on your formula chart, so you don't have to have it memorized, but you'll be able to go a little faster if you do have it memorized. So x, our variable, this is getting us our answer, equals negative b, or the opposite positive negative sign of b, plus or minus the square root of b squared minus 4 times a times c. All of that's underneath the square root. And all of that is the numerator, with the denominator being 2a. And you simplify as much as needed, as much as is appropriate for the situation, using the skills that we practiced at the beginning of the 0.3 notes in the previous video. So for 3a, that's already in the format that matches step number 1, so I can identify my a, which is 4, my b, which is 10, and my c, which is 3. A is always the number in front of the x squared. B is always the number in front of the x, and the c is always the number without any variable. It is possible for some of those to be 0 in some problem. Substitute into our quadratic formula, x equals the opposite of b. If b is 10, then the opposite, changing the positive negative sign, will be negative 10 plus or minus the square root. It's not going to be enough room for me. I'm going to have to move that down. Plus or minus the square root of b squared, so 10 squared minus 4 times a times c. All of that over 2 times a. So you're absolutely allowed to use a calculator to help you simplify this, but when the answers have to be exact, decimals are not going to be accepted. So using your calculator to simplify versus using your calculator to get the decimal answer, when that's appropriate, depends on the instructions you have for your problem. So you might want to check your instructions before you get too far with the calculator and see if it needs to be exact or if decimals are allowed. So following order of operations, we square before we do any multiplying and dividing. So 10 squared means 10 times 10, which is 100. Then multiply. 4 times 4 is 16, and 16 times 3 is 48. And all of that is over 2 times 4, which is 8. We need to do the subtraction inside the square root before we do anything else. 100 minus 48 is going to be 52. And we need to simplify that square root if we can. So 52 we'll factor into 2 times 26. 26 will factor into 2 times 13. 2 is prime, those branches don't go any further. 13 is also prime. Nothing else divides into 13 besides itself and 1. So that those branches all stop there. And we have a pair of 2's and a 13 that doesn't have a pair. So this has simplified to negative 10 plus or minus the square root of 2 times 13, because 1 from the pair gets to come out while the other from the pair disappears, and then the 13 that doesn't have a pair has to stay inside. And we simplify by reducing those numerator, both pieces, as much as possible. So negative 10 over 8 will become negative 5 over 4. And that's plus or minus 2 over 8 times the square root of 13 will become 1 over 4. You can write the 1, you don't have to. For my open math, those two answers need to be written separately. So negative 5/4 excuse me, plus square root of 13 over 4, and negative 5/4 minus the square root of 13 over 4. Which one you write first doesn't matter, as long as they're both there, being careful with your positive and negative signs. Sometimes in my open math you have to put one in one box, the other in a separate box. Other times you just put them both in the same box, separated by a comma. Okay, last example for this section. 3x squared equals 2x minus 4. This is not in the form that matches step number 1 because one side is not equal to 0. So I'm going to need to subtract the 2x from both sides and add the 4 to both sides. To get that 2x to move over, I need to do the opposite, which would be subtracting 2x. To get the negative 4 to move over, I need to do the opposite, which would be adding 4. Now my a is positive 3, my b is negative 2, and my c is 4. So x, my answer to my variable that I'm needing to do for this problem, is equal to the opposite of b. Well, if b is negative 2, the opposite of that, change the positive negative sign, would be positive 2, plus or minus the square root of b squared. Be careful with parentheses there, they are required, because negative times negative is a positive, and that negative needs to be squared as well as the 2, minus 4 times a times c. All of that's underneath the square root, and all of that is over the denominator 2 times a, where a here is 3. So negative 2 squared will be positive 4. 4 times 3 is 12, times 4 will be 48. All of that's over 6. 4 minus 48 will be negative 44. And simplifying the square root of negative 44, we've got negative 1 times 44. So we're going to have an I. 44 is 2 times 22. 22 is 2 times 11. Sorry, too many ones. 11. So we have a pair of 2's. The negative 1 that's inside the square root becomes an I, and then 11 that doesn't have a square root that's going to stay inside. So 2 plus or minus 2 that comes out, I from the square root of negative 1 part, 11 that stays in, all over 6. So separating, reducing, and because I'm out of room, should have given myself more room, sorry. Reducing and separating all in one step. This 2 on top on the outside, reducing with the 6 on the bottom on the outside, will become a 1/3 plus 2 on the top on the outside, reducing with the 6 on the bottom on the outside, will be another 1/3, but that one has an I times the square root of 11. And then the next one is that same thing, but with a subtraction. So that will end the video for